Good morning. Today we're going to mainly focus on scale factor and area. In particular, how does scale factor affect area? So we're going to look at our first question, which tells us to scale by 2. By now you're probably getting pretty good at scaling and doing area. So hopefully this will be an easy transition. So if we scale by 2, this is going to get 2 times bigger. So we're looking at 8, and then 5 times 2 gives us 10. So when we do the area of our 2 rectangles, this area, we can probably calculate it in our head, is 20, because 4 times 5 is 20, and then this area is 80. So if we want to look at what exactly happened to our area, well, we know it went from 20 to 80, so we know that it got bigger. So that's an easy thing to notice, it got bigger. But how many times bigger is what we're going to focus on today. Actually, if I scaled by 2, when we look at it, the area didn't just go up by 2, because if I say 20 times 2, I'm not going to get that 80. So we need to think about, how can I figure out how many times bigger it actually got? Most of you probably have already calculated in your head, well, if I go to 20 to 80, then that means it got 4 times bigger. But let's say we couldn't calculate that in our head. How could we work that backwards? If we wanted to work it backwards, we could say 80 divided by 20. And when we got 4, that would let us know that 20 times 4 is 80. So that's one way, if we have our calculator, if we want to work it backwards, we can work it backwards. So when we look at our area, we compared it, it got bigger, and it got 4 times bigger when the scale factor was 2. So now we're going to change up just a little bit and say, well, instead of 2, I'm looking at 1/2. So I know this has to be cut in half. So most likely you may already be saying, well, I know that my triangle is probably going to get smaller. It should get smaller if I'm going to make it 1/2, because that number is less than 1. So we're looking at dividing this by 2 or multiplying it by 1/2. It means the same thing. So we get 3 and 4. So this area and this area is what we'll focus on to start with. So 6 times 8, that's how we find area, length times width, like we did just a second ago. And 12, length times width is 12. Well, we've already established or thought about the fact that my area got smaller. So if it gets smaller, then we should be anticipating that our number is going to be less than 1 again, because our scale factor was less than 1. So again, we may not be able to think off the top of our heads what times 48 will take me down to 12, other than I know it's less than 1. So again, if we want to work that backwards, if you have one of these calculators or a different kind of calculator, if I say 12 divided by 48, that gives me 0.25. Or if I turn that into a fraction, that is 1/4. So it's smaller, and it's 1/4 times smaller. So the area didn't change only by 1/2, it changed by 1/4. So now we're going to scale this rectangle by 1/5. So we know that it's going to get smaller because it's less than 1. So I can multiply this by 1/5, or I can divide by 5, and that's going to give me 3. Same here, I can multiply by 1/5 or divide by 5, because that's the same mathematical concept, and I get 2. So my area is going to be 150, and then this area, which is still length times width, is going to be 6. So it's pretty obvious that my area gets smaller, but the key is to look at how much smaller. So if we work this backwards, because I can't do this in my head, so maybe you can, that's great, but if you can't, we can always do 6 divided by 150. So if I punch in 6 divided by 150, I get 0.04, and if I change that into a fraction, I get 1/25. So 1/25 times smaller. And I'm not sure if you made any connections when we were looking at all these problems. If you compare 1/5 and 1/25, that is like taking it to an exponent of 2. If we look at this one, if we look at the 1/2 and the 1/4, when we talk about area, that is taking it to an exponent of 2. Go back to our very first problem. If you look at the scale factor and you look at what happens to the area, it is still a scale. It gets an exponent of 2, because 2 to the second power gives us 4. And the reason why it doesn't change by only the scale factor is because we said length and width. So since we said length and width on both of these, then we end up saying 2 times 2, our scale factor of 2 times 2, which gives us our 4. So if I switched it just to do one more problem, I hadn't planned to do one, but let's do one more problem. Let's say if I scale by 3. If I had 5 and 4, if I scale that by 3, I know it's going to get bigger. So when we compare the area, I should already be thinking, yes, it's going to get bigger. So if it gets 3 times bigger, that's going to be 3 times 4 is 12, and 5 times 3 is 15. So my area is going to be length times width, which is going to give me 20. And then this is going to be 12 times 15. If we're not sure what that is, we can always grab a calculator. That's 180. So now if I want to know how many times bigger that is, if I work that backwards, I could do 180 divided by 20. So 180 divided by 20 is going to give us a 9. So if I wanted to double check that, 9 times bigger, I could do 20 times 9 and just make sure it gives me that 180. 20 times 9, and it does give us that 180. That's just a way of working it backwards. And you notice again, if you go to your scale factor and what happens to how many times bigger that area get, it is an exponent of 2, because 3 squared is 9. So I've got a few practice problems for us to try today. I hope you do well on those. Again, if not, feel free to reach out to me.